Hi everyone, in this video we're going to be talking about geometry definitions. The first definition is midpoint. Midpoint of a line segment is the point on that line segment that divides the segment into two congruent segments. In more basic terms, the midpoint creates two congruent parts. So for example, I have line segment AB, and notice that M is the midpoint. That's in the middle of the line segment AB. That divides the line segment into two congruent parts, AM and MB. Notice that these are the congruence marks, meaning that they have the exact same length. So for example, if AM has a length of 5, then MB also has to have a length of 5. A midpoint creates two congruent parts. Next, we have a segment bisector. A bisector of a line segment is any line that intersects the segment at its midpoint, thus creating two congruent segments. In more basic terms, a bisector creates two congruent parts. So again, looking at the diagram, I have line segment AC. And that is being bisected by DE. So essentially, DE is cutting through AC at point B, and when it cuts through, it creates two congruent parts. AB is congruent to BC. Notice the congruence marks. So again, if AB was 6, then BC would also be 6. So this DE is the segment bisector that's cutting through line AC and creating two congruent parts. A bisector creates two congruent parts. Next, we have an angle bisector. An angle bisector is a ray whose endpoint is the vertex of the angle and which divides the angle into two congruent angles. A bisector creates two congruent parts. So this time, instead of having a line segment, we have an angle. So for example, I have angle LKJ. And this ray, KM, is bisecting this angle into two congruent angles. So therefore, this angle here, which I'll call 1, and this angle here, which I'll call 2, are congruent. Therefore, angle 1 and angle 2 are the same. So if angle 1 is 30 degrees, then angle 2 is 30 degrees. So essentially, we're cutting that big angle into two smaller angles that have the exact same measurement. A bisector creates two congruent parts. Next, we have perpendicular lines. Perpendicular lines are two lines which intersect to form congruent right angles. So in this diagram, I have two lines that intersect, line A and line B, and they form congruent right angles. So here's a right angle, and notice it's represented by the box. That means it's 90 degrees. And if this is 90 degrees, so is here. Because remember, angles on a straight line add up to 180. 90 plus 90 is 180. Therefore, this is also 90 degrees, and this is 90 degrees. Perpendicular lines are two lines which intersect to form congruent right angles. Next, we have a perpendicular bisector. The perpendicular bisector of a segment is a line that bisects the segment into two congruent parts and forms congruent right angles. So essentially, a perpendicular bisector has two definitions in one. Perpendicular, which means we create 90-degree angles, and the word bisector, which creates two congruent parts. So let's look at the diagram. We have two perpendicular lines. Perpendicular means it forms 90-degree angles. So here are all the 90-degree angles. And it also is bisecting. So line R is bisecting PQ, creating two congruent parts. Notice the congruence marks. So PS is congruent to SQ, which means they have the exact same length. So if this was 5, this would also have to be 5. So again, for a perpendicular bisector, it creates two congruent right angles and two congruent parts. Next, I have a median. A segment drawn from the vertex to the midpoint of the opposite side is a median. So take a look at the example here. We have vertex A, and a line is being drawn from vertex A to D, and D is considered a midpoint because it breaks the line segment BC into two congruent parts, BD and DC. So again, a median is drawn from the vertex to the midpoint, and it creates two congruent parts. So BD is congruent to DC. A median is a segment drawn from the vertex to the midpoint of the opposite side. Next, we have an altitude. An altitude is a segment drawn perpendicular from the vertex of a triangle to the opposite base. Now notice you see the word perpendicular. You know perpendicular means 90-degree angles. So let's take a look at the diagram. I have a triangle and I have an altitude formed. So it's drawn from the vertex. So here's the vertex drawn down, and it creates a 90-degree angle. So whenever you see the word altitude, I want you to think of perpendicular, which creates 90-degree angles. Next is congruence. Congruence means it has the exact equal in size and shape. The sides have the same length and angles have the same measure. So notice in the diagram here, I have two triangles, and notice I have congruence marks. So AB is congruent to ED, CA is congruent to FD, and CB is congruent to FE. All the sides are congruent. Then let's look at the angles. Angle B is congruent to angle E, angle A is congruent to angle D, and angle C is congruent to angle F. So anytime you see the word congruence, it's exactly equal in size and shape, sides have the same length, and angles have the same measure. Lastly, I have the word vertex, which you've already discussed a few times. It's the corner point of a geometric figure. So in this triangle, I have vertex A, B, and C. They're the corners of a triangle, and inside I have my interior angles.